for this problem on the topic of quantum mechanics in 3 dimensions, we want to derive two equations. The first is L plus L minus is equal minus h bar squared d2 d theta squared plus the cotan of theta d d theta plus the cotan squared d2 d phi squared plus I d d phi. The second proof we want to show is that L squared is equal to minus h bar squared into 1 over sine theta d by d theta sine theta d d theta plus 1 over sine squared theta d2 d phi squared. And we want to do the first part, part A, by using a test function. So if we apply the operators L plus L minus to a test function f, we know this is equal to minus h bar squared e to the I phi into d d theta plus I times cotan theta d by d phi into e to the minus I phi times df d theta minus I cotan theta df d phi. Notice that all the derivatives here are partial derivatives. So we can write this as minus h bar squared e to the I phi into e to the minus I phi into d2 df d theta squared minus I into minus cosec squared of theta df d phi plus cotan of theta d2f d theta d phi. And this is plus I cotan of theta into minus I e to the power minus I phi into df d theta minus I cotan theta df d phi plus e to the minus I phi into d2f d phi d theta minus I cotan theta d2f d phi squared. So this, with some simplification, we can write as, we can bring out the minus h bar squared as a constant into d2f d theta squared plus I cosec squared of theta df d phi minus I cotan theta d2f d theta d phi plus the cotan of theta df d theta minus I cotan squared of theta df d phi plus I cotan theta d2f d phi d theta plus cotan squared theta d2f d phi squared. And so we can see that we can go one further, and we can write this as minus h bar squared into d2 d theta squared plus the cotan of theta d by d theta plus cotan squared of theta d2 by d phi squared plus I into cosec squared theta minus cotan squared theta times d by d phi, and all of this in brackets is an operator acting on the function f. So hence, we have shown, therefore, that L plus L minus as an operator is minus h bar squared d2 d theta squared plus cotan theta d by d theta plus cotan squared theta d2 by d phi squared plus I d by d phi QED. So that's the proof for part A as required. Now for part B, we want to show an expression for L squared as given. And we want to use the equations that are listed in the problem to derive this equation. Now we know from these two equations that Lz is equal to minus I h bar d by d phi. And from the second equation, we know that L squared is equal to L plus L minus plus Lz squared minus h bar Lz. So therefore, we can write L squared as minus h bar squared d2 d theta squared plus cotan of theta d by d theta plus cotan squared theta d2 d phi squared plus I d d phi. And this is minus h bar squared d2 d phi squared minus h bar times h bar over I times d d phi. And so we can simplify this even further as minus h bar squared into d2 d theta squared plus the cotan of theta d by d theta plus the cotan squared of theta plus 1 into d2 d phi squared plus I d d phi minus I d d phi And this simplifies even further to minus h bar squared into d2 d theta squared plus the cotan of theta d theta plus 1 over sine squared theta d2 d phi squared. And so this finally simplifies to minus h bar squared into 1 over sine theta d theta of sine theta d theta plus 1 over sine squared theta d2 d phi squared as required, and so QED.